Welcome back, guys, for another installment of the temperature monitoring system for the static compost. Um, in the previous video, the one before that, I show the output of the first actual running version, which I broke during the installation or whatever into the compost. So those carbon fibers, the tubes, their wall was so thin, it's less than 1 millimeter. And yeah, I decided to go with metal this time. So this is 1 inch square tube. These are half-inch, and that's 1 inch too. And I also did redesign the box. The circuit itself is the same. There's no change in the circuit, the main board. However, and also, yeah, the ambient temperature sensor. But the way that this works now, let's disable everything. Whoop, not that one. Yeah, let's disable all this. Okay, now what it looks like is there's still 27.5 inches, but there's these slots milled into it, and circuit of course will be inside, and there will be a cover here. The whole point of putting these screws in here is to be able to replace if in the case that something goes wrong with the sensors. And sensor boards are also changed. Let's look at that, one of them. And this is the same thing. Actually, this is in the previous video I explored the low pass filter, and this is the implementation of it. So this in schematic doesn't look like much, but that's the temperature sensor, 5-volt input, and then there's a decoupling capacitor, and then rest of it is the filter, and the output goes into this. This is just a single. It'll make much more sense when I show. Yes, there we go. So that's the output. These are ground. These are 5-volt. So what it is there will be string on a string. Well, power will come into this sensor and come out to the next one. So there's a chain, and this is the output, which will go to the board, main board. That did not change in this iteration. So due to the price constraints, I didn't want to spend too much on this. The capacitor value I came up in the previous video was 220, and I decided to go with 200, and still 220 more common anyway, but yet it was still more expensive in this size, because I want to keep the size as small as possible, yet these are still bigger size. So I think they are 2 millimeters by 1 millimeter, whatever. I parallel them, so capacitors, when you parallel them, they add resistors. When you parallel, well, in a series connection, they add. So they're inverse of each other, basically, in the terms of aggregating them or whatever, adding them serially and parallel. So 200 will in parallel would be 200, same as here, and then 100K. These are really small, 1 by half millimeter, because there won't be much current flowing through them. Not that I can think of. So those are the resistor. This is the sensor. Uh, this is just 2D, so there's a capacitor here, and the complementary capacitor that is parallel to it is on the other side of the board. Same goes for this, and this is the operation amplifier single. Because as I mentioned in the previous video about the evolution of this circuit, uh, this is very low impedance. So um, the sensor output sees very small impedance here, so it won't. I don't think we need any buffer or anything, so that's why I went with single, single what you call operational amplifier to bring down the size. Because if it was dual, then of course we're gonna have to have 8 pins, 3 for each and 2 for 3 pins for each 6, and you know, plus and a minus, or yeah, rails, so voltages, so you know, power, whatever is coming into the op amp. So that would take more space, and this thing would be, well, I mean, I could accommodate that. I mean, that's not a big deal. There are smaller packages, but I just want this readily, uh, you know, easily makeable. I mean, you can get some packages like quarter of this size, you know, like it's very tiny, but that's gonna be really hard to solder, which I can, but I'd rather just have it easy. This could be tiny. I can make this very small, you know, spend more money, make the capacitors are smaller, and make the connections are very, you know, tiny, solder pads, and then make really used. I mean, I could actually almost half the circuit, you know, by putting these on a, making these a pad, put it on the other side, getting a much smaller package of the op amp, getting a smaller capacitor. That would be, but what's the point? Because I have a ton of space, which shows here. If you look at the x-ray view, I mean, that's like I have space from here to here. Yeah, I mean, even if it's half of it, what's the deal? So there are several design, you know, parameters in here. So I did not need to have it that small, and I can solder all this by hand, so I don't even have to reflow solder or do a specific, you know, weird process to it. Just hand solder. And then here's the thing: these black. Let's take this off. That's not X-ray. Okay. So the sensor sticks out. The actual temperature sensor goes right through. Let's hide that. And these are 1 millimeter holes, which I had a whole bunch of micro drills, but over the years I used them on metals like an idiot and break them. So I ordered a new set, well actually a set of 5. Each has 10 different lengths. They're all identical, 5 sets, and each set has, I guess, from 0.3 millimeters all the way to 1.2. And in fact, I will probably make them even less than 1 millimeter. And this material is actually Delrin, which is black, you know, color. In this case, it could be different, I think. I'm not sure. Delrin might be just black, but it's not the same thing as high density polyethylene, um, which HDPE, high density polyethylene, and this cannot be glued. Hence, excuse me, hence the screw holes and uh, reciprocating threads inside on the boom. So this can be, I will still put glue underneath this and screw it in there. At least glue will be, you know, will provide insulation. And also I will pot like with a glue, put this in here to close. And the whole reason behind using some plastic is, I mean, I could just expose just a little hole in there and then glue this. No, I mean, this is metal now, and it will conduct the heat. And as the time goes by, the heat at this level will spread up. So the temperature of the whole thing will stabilize the same thing, and all the sensors will, um, measure roughly the same thing, which defeats the purpose of having 15 sensors. So you need to somehow insulate the what you call um, you know for temperature. So that's why these black Delrin, well, I mean, I made a test one out of you know HDPE, which I have a ton of, but actually I may just do HDPE for the purpose of this. It really doesn't matter. So also at the end, this is square tube, on the 90 degrees rotated offset, I made these holes, to hold. Where is it? There you go. This is I mean, I have round Delrin and rectangular HDPE stock, so I'll do these from HDPE, and this is from Delrin. So something pointy so I can just stick it. And I made a mistake. Well, I corrected it. With this program, I'm having a hard time making the shapes that I want. So, but this will be seamless looking when it's gonna butt up against this thing, and then that holes through will be going through this thing as well as that. It's a retaining, well, not retaining, but roll pin, or and there's a technical term for it. I don't care. It's just like guns have it too. I call it retaining pin. I think that's what it is called. But the packaging say roll pin or spring pin. So you basically punch it in there. It's supposed to be, you order it by a size. This is 1/8 of an inch, but the actual thing is this little, it is like a C, almost closed circle, but it springs, and it's more than 1/8 of an inch. So you basically tap that in place to hold this piece and prevent it from coming out. I initially thought of these that way too. I was going to put it through here, and I made this longer, and here one and here one, but I mean there's so many holes, plus those holes will need to be filled, because this will be in the compost and I'll water the compost, so this will have to be insulated, and having that many holes is going to be that much worse. So this is the, well, let's look at the circuit real quick. Take this one off too. Yeah, it's just as drawn in the right here. This 2D and the other one's 3D. So let's see. Nothing fancy. Oh, by the way, this is let's find out. This is 0.21. Come on. 0.21 millimeters by 3/4 of an inch. Yeah. So it's small. Like I said, I could make it smaller, but why? There's no need. And I decided against connectors. I'll just solder these. What I'm gonna do is, oh, when they're, I lay out from the main, I lay out each of the sensor output wires, cables, wires, yeah. So what I'll do is I'll give a whole bunch of slack. So I will take, these will be out, and I will put the sensor through here outside and solder it to, of course, the board. Now these cover uh, and the board and the sensor will be a whole unit, and it's right butting against the um, capacitors, which I'll probably not do that. This is plastic. You may have I don't know, static electricity or whatever. Well, I mean, it's just no, no, no. I mean, it will be grounded through. Oh, by the way, this will be grounded to the circuit ground, so um, it will also improve the noise of the sensors, because I'm transmitting 2.4 gigahertz, and it could very well do millivolts of voltage induced on the wires. Normal. Um, well, that's in a nutshell is gonna be what it is. I already soldered. I need to make have a better camera and make a good picture and some nice looking desks, which my desks are always cluttered because I have a bunch of projects. I know exactly where things are, but that's how I operate. I mean, well, every once in a while I make everything spotless, everything's everywhere, but as the time goes by, things move and left in place. But I always know what's where, unless other people come in and use this stuff and don't put stuff back in. I'm not gonna name any names. Anyway, so this is pretty much it. I already ordered the boards, and I have finished this boom, made all these, machine all these off work hours. In fact, I did it 11 o'clock yesterday, and now it's 10 p.m. So uh, what I'm doing, uh, this wasn't, my mill is, I got small Chinese mill, uh, hobbyist mill basically, and hobbyist, well, semi-hobbyist, better than hobbyist lathe I have. So I cannot do all these at the same time, so I did first three, and then the rest of them I referenced it off of this face, so they're all within a couple thousands of the drawing. And of course, it will never be perfectly square in here because cutters are round. There will always be a radius in here, but I ended up advancing this way a little bit and this way a little bit, so there's a little bit crown over here. So when this black thing, which I do it in the mill, can have these sharp corners, can easily be, it's a press fit, light press fit. It's not completely loose. And then, like I said, um, and this stuff I got from Home Depot. Of course, the square tubes are not perfectly square either. There's a radius in here. I measured it, and actually, this is what it looks like. I would have thought this would be a little bit, extended radius, but it's 6.2, 6.5 or something from here to here. So 6250, yeah, I think. Let's see. It is 6250 if you do it here, but I didn't pick it up from the exact corner or whatever. Yeah. Anyway, so this is looking pretty realistic. Like I said, I've already made these and it's working. Well, the holes here was kind of stupid because the only uh, drills I have left was one 95 millimeter ones, and it's wobbly like crazy, unbelievable. It it is terrible. But with this new stuff I have, they're going to be carbide drills, and I'll run them at 5,000 RPM into this plastic material. It'll just be like butter. So I've done that before for aluminum actually. Those bits are pretty good. They can do aluminum really good. Um, and then just holes comes out just spotless. I mean, perfect. And of course, the mill I have digital readout, so I know I can get it within thousands. It will look decent. I'll probably have an actual video with the camera and whatnot to show all these completed parts, but I don't have time. That's why I never do, and I'm strongly planning on not doing any editing ever. It just takes time. I mean, you just get the gist of it, and see what I'm up to and what I'm thinking. Uh, Besides other things, all these projects and stuff. I got a ton of other stuff. I just don't have time. This is the something that I'm actively working on. So that's why I'm making these videos very, amateurly. Just no editing, nothing flashy. Everything looks okay. I've done, yeah, prototypes and all such. So okay, yeah, this is an interesting point. So remember, the width of the finished board is 0.21 inches, and the width, the length or whatever, the width and length is 3/4 of an inch, so for 0.75. But the OSH part that I use, OSH part or whatever, open source hardware part, oshpark.com. I really like them a lot. The boards come out just like this, just like shown in here. Gold, electrolysis, nickel immersion gold or something, ENIG, ENIG or whatever finish, gold plated basically, and just like that. See, notice I don't have this bump over here. The reason I do the bump is their minimum required dimensions are 1/4 inch by 1/4 inch, but this is, instead of making this wider, because it's gonna be the same price. I'm paying same price as if this was like this, because they're just calculating the price off of longest length and longest width. Longest width is here. Surprisingly, where's this thing? Oh, 1/4 inch, and the other one is, come on, 3/4 inch. So I'm just doing this so it can be manufactured. I'm sure they can do smaller ones, but they just don't want to, deal with it, because the whole idea of this, place that I'm buying this thing is they take designs from a ton of other people, they put it in a panel. What it is, they come up with some kind of placement algorithm. So the panel is, I think, 1 meter by, I don't know, 40 centimeters, so 1 by 0.4 meters. Um, you know, they use the algorithm just places these people's board uh, efficiently into one panel. So normally, if you go straight to the board house to get your stuff built, they charge you a setup fee and all that stuff. So what happens is the reason these guys, OSH Park, Osh Park, whatever, are able to do this cheaply is that cost. Probably they negotiate that way anyway, or you know, make it really low, and that even that is shared amongst everyone in the panel. Could be hundreds of different designs because this takes absolutely no space. But they do 3 panels, so if you order, you get multiples of 3. So you have one order, you get 3 boards. You get 2 orders, 2 sets, you get 6. So I had to order what, 30? I think more than that. Well, not 30. 15. I think I did 50. I don't remember, but it's gonna I'm gonna get enough for. So when I get them, I'll just either mill or um, file this away. I intentionally put these stops in here so this copper thing wouldn't flow in here, and by me milling or filing this, wouldn't accidentally uh, touch these power layers, because one is positive, one is negative. You connect them short. So they have rules how close you can get to the borders, but this is wide enough. I mean, I could have just make it really small, but there's also tolerance to that too, so I just kind of make it this way. And when I make it this big, it just, this flows in here, and when I, get rid of it, I will have exposed inner layers on this side, which I don't want that. You don't want that. Nobody wants that. So there's no reason to set yourself a failure. It's just um, that's it. And I always this is backwards, but 2039. I mean, it's a common thing. It's a year and a week. So 2020 and the week of 39, last week, I guess. And temperature sensor board version 2. Actually, this is 2.1, because in 2 I had a little bit bigger. I just condensed it a little bit. Spaces in between. It's not going to be a problem. Everything's clear. So, I mean, even this is fine. I have enough. Each square is 5 thousandths, so this is almost 8. Yeah, it's about 8. I would say 8 thousandths space between, and the minimum for 4-layer board, the design restriction is 6. So I've done, right at 6, and everything would be fine. Like I said, that Osh Park, whatever, they're really good. I've been using them for 6 years now. I got hundreds of boards. Price is not bad. For 4-layer, it's $10 per square inch, and for 2 layers, it's $5 per square inch. And I do, I get some stuff from China, used to anyway, and sometimes it makes sense to order from there. This level of finish, it costs, I think, more. Plus, if you want to get it anytime soon, well, in China they can make it real fast. But oh no, there's something here. What is this? Oh, it doesn't belong to that. I don't care. Um, China, it gets done real fast, but the problem is to get here. It's not, I always end up paying for DHL $17 to $23, depends on what DHL feels like charging that day. But it gets, within 5 days. It gets done in 3 days. You can get it back early. But in the Oshpark, which is in Oregon, you can get free shipping. With the fires and USPS the way it is these days, I actually use UPS. It's $7.99 today. It's actually not a bad price. It's usually like 16 something. But board doesn't cost anything really that much. The size is small, so it will be fun to put all these 15 together like I did on the other ones. But this is a little bit more involved. The other boards were like just temperature sensor and a capacitor, but this time I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different components, which is a double-sided load. So do one side, and I'll just do it by hand. It's not really worth bringing out the solder paste and going over there, bake it, and and it takes long enough time. You can't just do this, whatever, and then bake it all together, because by the time, it still takes time. By the time you finish this one and then this one, this or third one or whatever, this may get dried. You don't want, the flux in it. It gets crusty if it sits outside. Plus, on my bench, I got light coming out and like extra heat. So just do it by hand. There's nothing. My eyes are not bad. My lenses are screwed. This is my fourth pair through the same place. I cannot seem to get it right. But my eyes are getting to the point. This 0402 size, like 1 millimeter by half millimeters, I can still see them, but I much prefer using that mad scientist glasses visor kind of thing with a magnifier. The lowest magnification, makes it look much better. I had a camera, you know, I hacked some kind of document scanner, and yeah, but resolution is not good. It's optically, you know, optical zoom and all that stuff. They sell stuff like that, but I don't. You know, I can still do it by hand. When I have problems start to have problems seeing them, then yeah, that's another issue. So that's it. This is the video I wanted to make. I wanted to make last night, but I almost fell asleep on the computer. I'm sure you heard me yawning a couple times today. And that is pretty much it. Let's see what else. Nothing. Yep. Yeah, there you go. That's it. In my next video, I will show probably the last boom I'm gonna make. I made one black piece and one boom already, and I learned things, and this is the updated design, more realistic. And then I accidentally made this thing wider, and I switch it, I redesign it to be wider that way. I mean, it's not necessarily, there were like a 25 thousandths narrower on each side, so 50 thousandths. What is that? A little over 1 millimeter. I mean, it's just what it was. It was 300 thousandths, so it's 350. Because I put quarter inch 250 in the middle, and I went 50. I should have went 25. because the half the radius, half of 300 minus the um, radius of the bit was 25,000. But I just basically subtracted 300. You know, this was 300. 250 from 300. Like, oh yeah, 50. I just forgot to divide by two. It's split evenly to both sides. So I accidentally widened. I was like, oh, well that's okay. I mean, I'm still not at the edge. Um, it'll be all fine. So when I put these, actually, they're a little uh, because of the radius in here. There's a little bit hanging in here, and that's perfect spot for glue to hold on. Glue will hold on to this, and of course I'm gonna black spray paint this anyway, so it won't stick onto this. This material is like not, things don't stick to it until the glue and paint. So I mean, I'm sure there are other techniques you can do, but this spray paint and whatever is not gonna stick. So the whole in the next video I will show, hopefully if I can set it up, some machining, and I'll show some of the finished boards. I ordered the boards, but they will be coming in probably a week and a half. They're sent to the, I get emails like, yeah, they're sent and they're being made. They just digitally send it. They don't send anything. They submit the order to the actual manufacturing place. They don't manufacture it themselves, the Osh part. And their boards are always, well, they recently added dark version, which is like flat black. This is it, but they're like staple colors, orange, purple. It's getting too late. It's 10:30. I can't believe I'm sleepy. Alright, well, that's it, guys. I hope you enjoyed it. It's probably too long, but see you in the next one. Stay safe. Don't catch that COVID crap. And have a good one.